Okay, right. So we are going to continue now, but before we continue, let's just do a refresher. Okay, right. So we are touching on wind turbines. This is an introduction to wind turbines. Okay. Then what we've noticed here is we have the orientation of axis of rotation, and then the subcategories of that it would be what we call hot and vot. Hot, HAWT. It simply just means horizontal axis wind turbine. Okay, and then you have vot, which is just vertical axis wind turbine. Okay, and then mechanism that provides torque to the rotating shaft. Now, what's the difference between what you see on your right and what you see on your left? The difference is we normally have to categorize wind turbines. Simply meaning we have to categorize them. Okay, then for now, I'm of the understanding that there are two ways of categorizing them. It's either orientation of axis of rotation, or it is mechanism that provides torque to the rotating shaft. And when we refer to mechanism that provides torque to the rotating shaft, we normally looked at it as in lift type or drag type. When we say lift type, drag type, it is speaking to the mechanism that provides torque to the rotating shaft. Okay, right. With that being said, there's just one last thing that we also have to touch on. Okay, right. What is this other thing? Okay, right. There's 3 points here. Okay, and this is a graph, and then this over here will obviously be, for now, let's call it power, electrical power. Okay, right. And then this over here is going to be speed. Speed is normally denoted with a V. Okay, right. So this is our y-axis, x-axis. On the y-axis we have electrical power. On the x-axis we have the speed. Okay, right. Now at point A, point B, and point C, what do we have? Okay, what we have now is the following. At point A, we have what is called cut-in speed. Okay, at point B, okay, we have what is called rated speed. Okay, and then at point C, right, we have what is called cut out speed. Okay, now obviously I'm just going to define this, and then you will obviously have to write this down. Okay, so what is cut in speed? Cut in speed, it's normally the minimum speed required for the turbine to generate or produce useful power for the purposes of consumption. That's it. I want to consume power, however, I need a minimum speed at which the turbine can produce or generate usable power. Okay, minimum speed. That minimum speed, we refer to it as the cut-in speed. Okay, then rated speed, that is the speed, the maximum speed at which a turbine is normally, you can say manufactured, but the more accurate or engineering term to use would be to say design. When we design a wind turbine, we are designing it for, let's say for instance, maximum power output. Then that maximum power output, it is associated with a speed, and that speed in this case we refer to it as rated speed. Okay, then we also have at this point, yeah, we have cut out speed. Now when we talk about cut out speed, what exactly do we mean? We mean a speed beyond rated speed. Okay, and when I say beyond, why do I use that word? Because that word can be associated with a dangerous speed. Okay, a speed whereby we now have to apply braking mechanisms to the blade to the blade or the rotating segment of the turbine. Okay, so simply meaning the moment the speed goes above and beyond rated speed, now it's in a dangerous territory. Okay, it's still going to generate power, whatever, but the objective at that point, it's not to generate power. The danger at that point is to say, listen, now you are operating outside the design specifications. So for that, we now need to apply braking so that the speed can be reduced to a point where it's either rated speed or below. So yeah,